memory is relatively slower compared to processor. Processor is super fast, and to match its speed, we need a high-speed storage device. Therefore, cache, a fast storage device, is introduced as a storage bridge between main memory and processor. And this is usually placed on the processor itself to avoid any hardware delay. The advantage is it is fast, but the limitation is its size. It is much smaller compared to the main memory. Therefore, at any instance, only a small set of data can be copied from the main memory to the cache. Now the question is, which set of data has to be brought to the cache so that the performance of the processor is high? If you think for a minute, you can easily make out. It's either frequently used data or closely connected data or sequential data. This frequently used data is technically called as temporal locality or locality in time, and closely connected data is called spatial locality or locality in space. This referencing the data is called locality of reference. To have a better understanding, let me give you a real life example. Imagine you're packing your bag for your college. Generally, we make sure to carry a pen and a rough book. The reason to pick up a pen or a rough book is its frequency of usage. You're going to use it again and again. This item set can be compared to temporal locality, where frequently used items are picked up. On similar lines, it will be beneficial to fill the cache with frequently used data so that the CPU average access time will be less and the performance will be more. For example, if you think of a for loop to count the numbers, the count is called again and again 10 times. If you place the instruction related to count in the cache, then you are using the logic of temporal locality. Okay, now coming to spatial locality, just imagine that today you have computer organization class and your faculty has told you to bring the textbook, but he did not mention which textbook. Then what would you do? You would pick up all the available CO textbooks from the rack and then you might dump them in your bag. You may do this because the probability of usage of any of these items is high as they're closely related. So this can be compared to spatial locality where the data items are compared with some reference. And in cache, if you think of any structural program, instructions are executed in a sequence. So if you fill the cache with instructions whose addresses are in sequence, then you're using the logic of spatial locality. Okay, I hope you're clear with the concept of locality of reference. Now comes the next big question. How do we map the main memory with the cache? For this, we'll be using three techniques. 1. Direct mapping. 2. Associative mapping. 3. Set associative mapping. This is a very important topic for GATE. Many numericals are asked from this topic. So a clear understanding of fundamentals is very much required. So let's start with direct mapping. For this, let me take this example. Imagine you're packing your bag for your college. Here, let's assume the bookshelf as main memory as it's a big storage, your bag as cache, a small storage, and you are the processor as you will be using them. The bag has 3 zips or partitions and each can hold only one book. And you have labeled the first zip as CO, second as OS, third as CN. Now if you pick up Morris Mano's the CO book, you are bound to place it in the first zip. Similarly, if you pick up CN book, you will place it in the third zip. So the placement of the book is determined by the label. Suppose this is the bookshelf and this is the bag. Any CO book will be placed only in zip 1, OS in zip 2 and CN in zip 3. If you think in terms of functions, direct mapping can be thought as a many to one mapping. If you compare this to cache, in direct mapping, cache partitions are called lines and they have line numbers. In main memory, partitions are called as blocks with block numbers. These line numbers can be thought as labels, and the mapping logic is block numbers least significant bits are mapped with the line number. So line 0 can hold the blocks 0, 4, 8 and 12. Then line 1 can hold 1, 5, 9, 13 and so on. Here in direct mapping, the advantage is by using the physical address, you can easily locate the line in the cache and check if the data is available. But the disadvantage is because of the labeling, there is a restriction on the placement. The block 0 has to be placed only in line 0, not in the other slots, even though they are free. And this restriction is an overhead. And to overcome this, we have the second mapping technique, associative mapping. In this, we will not label any zip. You are free to put any book in any zip. On similar lines, a memory block can be placed in any cache line. Here the advantage is flexibility on placement. But the problem is we are not sure where the data items are. Therefore, we need to search each and every line. So this search becomes an overhead. And now comes the third mapping technique, set associative mapping. Imagine you purchased a bag with 2 zips and each zip has 2 internal partitions. Now let's label zip 1 as morning and zip 2 as afternoon, so that you can keep all the morning slot books in zip 1 and the rest in zip 2. The labeling is for external zips only, so you're bound to follow this logic. But inside a zip, you're free to place the book anywhere. Now if it's morning session, you will search in zip 1, and if it's afternoon, in the zip 2. Here the search overhead is reduced by half, and that's a major improvement. And if you closely observe, this is actually a combination of direct and associative. In this mapping, cache lines are grouped as sets, where block number least significant bits are matched with the set numbers, which is a direct mapping. Inside a set, you are free to place anywhere, so associative. Because of the grouping as sets, the search overhead is reduced drastically, and the performance is improved. Alright, let's put all the mappings into one single frame. In direct mapping, each data item has predefined placement location. In associative, no restrictions, you can place the data anywhere. In set associative, an item is tagged to a set, and inside the set, free placement. Okay, this is just an outline of the mapping techniques. We shall review each one in detail in the upcoming videos.